Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6C assignment. First one to take a look at is number 1. State the y-intercept of the function. So remember, when we have the y-intercept, that's when x equals 0, right? So I'm just going to plug 0 in for the x's. So in this one here, we'd get y equals 0 squared plus 2 times 0 plus 3. So that is going to be 0 plus 0 plus 3. So the y-intercept is going to be 3 on that one. Okay, same thing for this. Plug in 0 for the x's, so we get y equals 8 minus 0 minus 2 times 0 squared, right? That's a 2 right there, not an 8. Just my pen messed up there. So that's 0, so we just get that the y-intercept is 8. Okay? All right, taking a look, number 3, find the x-intercepts of the function. So if we're looking for the x-intercepts, that's when y equals 0. Okay, so I'm going to put a 0 in for this y, so we get 0 equals x minus 2 times x minus 5. Okay? So when does this equal 0? It's either when this, like for this whole side to equal 0, the null factor law tells us that either this has to equal 0 or that has to equal 0. So our x-intercepts will have to be when, let's see, 2 minus 2 is going to give us 0, and also 5 minus 5 will give us 0. So those are our two x-intercepts. Okay, same thing here. Plug in 0 for the y. 2x minus 3 times x plus 1. So what makes this, what makes this equal to 0 is negative 1. That's not too bad. So x-intercepts are negative 1 for this one. Now this one here, if you're not sure, just set that equal to 0. 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. Divide by 2. X is 3 halves. Okay? Now, there is a nice way to do that too. What's going to happen with, we're starting with this 2x minus 3. We know that this here is going to have to get moved to the other side. So it's going to be the opposite of this number, the constant. And then you end up having to divide by that number every time too. So it's going to be the opposite of this number divided by that number. So it's 3 over 2, just like what we got there. So for example, if we had 5x plus 7 equals 0. Take the opposite of the 7, and that's negative 7, and divide it by 5, and that's what your x-intercept would be. Okay? That's a separate one. This is what we're really looking for. Okay? Number 4, how many zeros does a quadratic function have if it cuts the x-axis twice? So if it cuts the x-axis twice, that means it's going to look like this, or something of that nature. So how many zeros does it have? If it cuts it twice, it's going to have 2 zeros. Okay? If it just touches the x-axis, it's going to look like this, or like this, something like that. So that would have exactly 1. And if it lies entirely below the x-axis, like this, or something like that. That's not a very pretty one. That's not really a function here, but you get the idea. Then that would have no zeros, right? Okay. Moving on to number 5. Find the zeros of the following function. That is the zeros are when it crosses the x-axis, so the x-intercepts. Right? And so that's when y equals 0. So we'd have 0 equals x squared minus x minus 6. So we are going to have to factor this thing out. Factors of 6 are 1 and 6 and 2 and 3. Which ones of those have a difference of 1? That's going to be the 2 and the 3. So x, 2, 3. This sign in the middle always goes with the bigger of the 2. And then a negative times a what gives us a negative? Negative times a positive. So our x will equal, our x-intercept is going to be negative 2 and positive 3. Okay, whoop, there we go. And for this one here, same thing, 0 equals negative 2x squared plus x minus 5. Now this one is not, does not have a leading coefficient of 1, which makes it much more challenging to factor. Okay. Now, something that you might want to consider when you get something like this is to just start plugging into the quadratic function, because the quadratic function will always give you an answer. Because like if we try to do this and it's not factorable, then we end up kind of wasting time. We have to go to the quadratic anyway. So if it's, leading coefficient is 1, do the nice easy factoring. If it's quadratic like that, like with a leading coefficient that's other than 1, I would suggest just plugging it into the quadratic, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Nice thing about this will always work. It will always help us find our answer. Okay, so in this case here, our a is negative 2, our b is 1, because that's 1x, and our c is negative 5. So we get negative 1 plus or minus 1 squared minus 4 times negative 2 times negative 5 all over 2 times negative 2. So we get x equals negative 1 plus or minus, that's a plus or minus, that's a pretty poor plus. There we go. And then we get 1. And then negative 4 times negative 2 times negative 5 is negative, it's basically positive 8 times negative 5 is minus 40 all over negative 4. So we get x equals negative 1 plus or minus the square root of negative 39 over negative 4. Now, as soon as we get to a negative root, that right there tells us there are no real solutions. Okay, meaning that this graph here, since it's negative 2x, it's going to be somewhere fully below the x-axis, so it will not have any zeros. No real solutions, no zeros. Okay? All right, one last one to look at. Number 6, find the axes intercepts of the function. So that's x-intercept and y-intercept, right? So x-intercepts, that's when y equals 0. And then the y-intercepts, or intercept, because there's only one of those, and that's when x equals 0, right? So you can choose whichever one you want to do first. Let's try this one, A. Let's find our x-intercepts. So that's going to be 0 equals x plus 2 times x minus 1. So we get, look at, we're already into the zeros here. So x-intercepts are going to be whatever makes this equal to 0, negative 2, and whatever makes this equal to 0, positive 1. So there's our x-intercepts. And then the y-intercept is when the x equals 0. So that's y equals 0 plus 2 times 0 minus 1. So y is going to equal 2 times negative 1. So y is negative 2. Y, let's go back and change that into y-intercept equals negative 2. Okay, so there's our x and our y, x-intercepts and our y-intercept for A. Okay, so for B, do the same thing here. X-intercept is when the y equals 0, so we get 0 equals x squared minus 7x. We don't have a constant out here, so I would say factor out an x of both of these, make our life easy. And that's going to be x times x minus 7. Okay, so our x-intercepts are going to equal 0, because 0 times negative 7 will give us 0, and also 7, because 7 minus 7 is 0, times the 7 is still 0. So those are our x-intercepts. And then our y-intercepts are going to be y equals 0 squared minus 7 times 0, which is going to basically end up, those are both turning into 0, so our y-intercept keep doing that. Y intercept equals 0. Okay? Okay, that's all there is for the 6C assignment. If you have any further questions, please feel free to ask. Thanks.